So hello and welcome to React Nexus everybody. So that was actually pretty embarrassing. My manager came up to me and he's like, hey Shruti, every time I call you, you seem to cut my call. And then I check my block list and I'm like, damn, his name is there on the block list. So anyways, moving ahead, I'll quickly set the agenda for today. So I'll be covering the different ways in which, or the different tools using which you can measure performance in React Native. So a bit about me, I've been working with Flipkart since over a year as a UI developer, and I've been working in the UI domain since the past 5 years. During the weekends, I'm mostly Netflixing and chilling, and I like traveling to the mountains a lot. So how many mountain people over here? Wow, that's quite a lot. Okay, so before we move into the nitty-gritties of how we can measure performance and what tools we can use, I would like to actually discuss a problem statement with you guys. So while I was working at Flipkart, we started observing that with a lot of new features getting added to the Flipkart app and so many developers pushing in code parallelly to the code base, we started observing a lot of scroll issues on the Flipkart homepage. So we were basically observing a lot of jankiness as you would scroll through the Flipkart homepage. Now this was happening majorly on the lower end Android devices. Okay, so before I move ahead, what does jankiness, what do I mean by jankiness exactly? So as you would scroll, you would basically observe a lot of white spaces. So the white spaces was probably because the components were taking a lot of time to load. Also, while you would scroll, you would observe slight shifts in the components, probably by 1 pixel or 0.5 pixel. So just imagine, you're scrolling. Again, this is on some very lower end Android devices. You'll probably not observe it on your high-end iPhones or any other Android device. So just imagine if you're scrolling and you're seeing that the components are slightly shifting up and down by 1 or 0.5 pixel. So that's a very, very bad user experience, right? So now, the issue was very simple, yet it was very, very vague. So at any point, the home page was rendering approx 15 to 20 components, and it was very, very difficult to figure out who was the exact culprit. So which component was actually causing this delay. So we started measuring everything analytically to understand how deep we were into this problem. And as Apurva also mentioned yesterday, measure first and optimize later. So following the same principles, we started measuring few parameters, like the exact delay in each component load, how many frames were getting dropped as you would scroll through the page, and if there was any JS thread blockage or UI thread blockage while scrolling the page. So for measuring all of these parameters, we started using a tool called Flashlight. So not this flashlight, guys. How many of you have used Flashlight for measuring React Native performance? Wow, but that's very few hands I see. So I'll tell you what is Flashlight, how you can use it, and if you're working on React Native performance, you should definitely use it. It's a very, very powerful tool. So Flashlight is basically a lighthouse monitoring tool for React Native, and we used it for measuring the JS thread and UI thread blockage in real time, as well as we used it for measuring the frame drop as you scroll through the page. Now, if you look at a typical Flashlight dashboard, right, it looks something like this. So now you see the first graph over here is for the FPS, basically the frame rate per second, and it is measuring it in real time. So my application is actually running on the emulator, okay? And this graph is side by side measuring the FPS at each and every point as and when the components are getting loaded. As I scroll, you see the graph is moving. Now we are measuring some other properties as well, like the total CPU usage. Again, this is in real time. If you see the graph is moving, and it is constantly measuring the total CPU usage. We have other properties like React Native JS thread CPU usage, RAM usage and all. Now, if you closely observe the graph for frame rate, right, you will see that at some particular point, the frame rate has dropped to 5 FPS, right? So that was a really, really big problem for us. So frame rate dropping to 5 FPS is really, really not great. And for those of you who have actually worked with React Native performance, you would know that the average FPS should be closer to 60 in order to have an impression of fluidity. So now we started getting into the nitty-gritties of things. So now we wanted to measure the component-wise contribution to the overall delay. So again, getting back to the parameters that we were measuring as part of this was the time to first render each component, the number of re-renders for each component on page load, and the time taken for each re-render. So again, for measuring all of these, we had to use a tool. So we used the Profiler API. So again, how many of you have used Profiler API? Wow, here I have a good number now. So even if you haven't used it, you should check it out. It's again a very powerful tool. So according to React, a profiler can be added anywhere in a React tree to measure the cost of rendering that part of the tree. It's a very, very powerful API, and it's going to give you component-wise what is the performance implication of that particular component. But now, we were not using Profiler API directly. So we built a module, a node module, or a wrapper on top of Profiler API, and that is what we were using. Now you might ask me, hey, so Profiler API is giving me all the data. Why do you even need to create this wrapper, right? So don't worry, I'll answer that question of yours. So I'll tell you the difference between using React Profiler API directly and why we were using the wrapper on top of it. So if you see the right hand side code, I have wrapped my navigation component with Profiler, okay, and it takes a callback. Now, in the onRender callback, it is giving me a ton of information. Okay, we'll see that later on what information it is giving us. Now, for every page, for every component, you have to wrap around the profiler, pass in the callback, and for every page, you have to implement the onRender callback, right? And you might also have to write some aggregation function. So we created a node module on top of it. So if you see now on the left-hand side, my module name is component profiler. I'm importing a component called hijacker from this. So now your life becomes very easy. Just wrap around your component with hijacker and it will take care of everything. All you need to do is pass in your component name and then that's it, that's done. So now it will take care of, it will start measuring your component performance starting from the initial page load as well as if you perform any kind of action. So that's a lot of talking, guys. Let's see some demo for it. So before I tell you how the component profiler wrapper is working, I'll show you a very simple, very basic cart application. So I have a list of products over here, okay? Now you can add any item to the cart. So here is my cart component, and here I have another component called price summary component. So in totality, I have three major components on this page: the product list, the cart component, and the price summary component, and all these three are working in sync with each other. So let's say I can increase the quantity of a product, I can add another product, and similarly my price summary is also changing according to that. I can remove a product. So now I have already integrated the component profiler wrapper over here, and we'll see how that is working. So I'll reload the page. Now my wrapper has given me some measurements, okay? We'll see what these are. So if you see the second last table, it is giving me some measurements for the product list component, okay? It is telling me that the number of re-renders for the product list component was 3, okay? The time to first render the product list component was 0.59 seconds. And if you see the object in detail, you will see I am also showing an array over here which shows me precisely how much time it took for each and every re-render. So basically over here it took 9 milliseconds to re-render product list component for the second time. So that's a slightly higher number as compared to the other values, right? So this might be slightly problematic and we might have to debug why this is happening. Similarly, if you see the cart component over here, it has re-rendered 3 times and time to first render was 0.5 milliseconds. And similarly, you can see the time it has taken to re-render the subsequent times. Now, this was all about the initial page load. Let's see what impact does an action has on all these components. Let's say I add an item to the cart, okay? Now, if you see, the product list component has 4 number of re-renders, which is 1 more than the previous one. That means when I added an item to the cart, the product list component re-rendered once. Similarly, the cart component also re-rendered once. So from 3 it has become 4 now. But the price summary component did not re-render. It was rendered only 1 time. So now I'll show you one more interesting thing. I'll increase this, I'll add an item to the cart. And now I will remove one item. Now, if you see, from the last action had the price summary component re-rendering 4 times. And now, after the remove action, my number has increased to 6. That means that particular action has led to 2 re-renders. So that is slightly problematic, right? Now we started using this particular component profiler wrapper on our Flipkart homepage. And when we got the results, it was very, very surprising. So I'll tell you why it was surprising. When we started measuring the performance component-wise, we observed that this particular carousel on the top of the homepage, the number of re-renders that was coming up for this was approx 50 to 60 times. So every time each and every image would load, it would again and again re-render. Okay? So there are 10 images currently. So after every image loads, the number of re-renders becomes 20. And with each image changing, there was again and again more number of re-renders, and it was completely going on and on happening. So my logs were completely getting filled up. So that was the issue, and that is how, and then we went on to fixing this particular carousel, and that actually led to slight improvement in the performance and the metrics. So that is how we actually use these tools to improve performance on the Flipkart homepage. So that was it about my talk. Thank you so much, everybody. Note, if you want to check out the component profiler wrapper, you can go to my GitHub profile and you can check it out over there, or the link is also there on my LinkedIn bio. So that's it. Thank you so much.